look at in this video is we're going to practice using the 4 shortcuts that we learned about yesterday to prove that two triangles are congruent. And we're going to use that to show that corresponding parts of congruent triangles are also congruent. So what I want you to do is I want you to attempt the launch activity. You're going to construct 2 congruent right triangles, and I want you to explain how you know that they are congruent. And I want you to try to do that in a paragraph proof where you write out what you know and how it proves that it's congruent. So go ahead and pause the video. When you're done, unpause the video and we will go over the warm-up before we begin the rest of the notes. Alright, so on the right of the screen, you'll see I have gone ahead and I constructed 2 right triangles, and what we want to do is we want to explain how we know they are congruent in a paragraph proof. So if we look at this, and if I were to actually label these points A, and then B, and C, and D, E, and F, then that way we can refer to the sides and different angles and stuff like that. What we can do to prove that these are congruent is you could see that I first created a perpendicular bisector. So once I created the perpendicular bisector, we know that B and D are both 90 degrees. So we have that information. Then if you were to take our our compass and measure these, you'll see that I actually created this side and this side congruently. I duplicated the same length on each of those perpendicular bisectors, and then I also duplicated the same length on these 2 sides right here. So we don't really know the measurements of A or C or E or F. We don't know any information about those. But if you look over here on the left, I'm going to write our paragraph proof for this. So what we know is we know that side AB, so we know AB is congruent to ED. And we know that because we duplicated the same side there. And we also know that BC is congruent to DF. And since both of those lines are perpendicular bisectors, since both ED and AB are constructed on perpendicular bisectors, then we know that angle B is congruent to angle D, since both segments are perpendicular. Now, once we know that, we can then say by, now so we have side, angle, side. We have corresponding sides right here. A, B, and ED are congruent. This angle B and D are congruent. It's included between AB and BC, and then BC and DF are corresponding and they're congruent. So what we can say is we know that by side, angle, side, triangle ABC is congruent to triangle EDF. And you might be asking, why did I not say DEF? Why did I not say it in alphabetical order? That is because when you're saying 2 triangles are congruent, you need to start with the same corresponding side. So A corresponds with E, so A and E would need to be the first. Since I started with A for the first triangle, I would need to start with the corresponding angle for that second triangle. And same thing here, I went from A to B, so I went down to the right angle, so it would be D and then F. So when you are writing your congruencies, you need to make sure that you write especially for triangles, you need to make sure you write the letters in corresponding order. Okay. So in 4.5 and 4.5, or 4.4 and 4.5, we discovered 4 shortcuts for showing that 2 triangles are congruent. Those shortcuts were side, 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 angle, and side, angle. And what we learned is if we have corresponding parts on triangles, where we have three corresponding sides that are congruent to each corresponding side, where we have a side angle side that's congruent on one triangle to the corresponding parts on another triangle, and so forth, that we know those two triangles are congruent, regardless of whether or not, what we know about the rest of the parts of the triangle. And by definition of congruent triangles, it states that if two triangles are congruent, then the corresponding parts of a triangle are the corresponding parts of those congruent triangles are congruent. So we have that statement here, and what we are able to say is that if two triangles are congruent, and regardless of the information that we know, we can say that all corresponding parts of those congruent triangles are congruent. And so that's very important. And what we're going to do is we have a little shortcut of writing that. We don't want to have to write all those words every time. So we're going to call it CP, CTC. CP, CTC. So when you need to write corresponding parts of those congruent triangles are congruent, you can just write CP, CTC. Now, let me exit out of this dual screen here. So what we're going to do is we're going to go through a bunch of examples on how to use the four shortcuts and use CP/CTC in order to find out whether or not different parts of a triangle are actually congruent. So if we look at this first example, we'll see it asks, is AD congruent to BC? So what it's asking here is AD right here, this base side right here, congruent to this side up here, BC. So there are no congruency markings on it, so we have to use information that's given in this picture in order to figure out a deductive argument about why they must be congruent. So if we look at this, we want to write down all the information that we know. So first things first, we know that angle A is congruent to angle B. And we also know that side AM is congruent to BM. We know that because it has the congruency markings on it. And then if you look at this, you might be wondering, is there any other information that we know? And the answer is yes. If you look at angle 1 and angle 2, those are vertical angles because they are two angles that share a common vertex. So, and no sides. So since those two angles are vertical angles, we know that angle 1 is congruent to angle 2. Now, if you think about this, what do we know? We know that, let me erase some other these colors on here. So here's what we know. We know that 2 is congruent to 1. We know that B is congruent to A. And then we also know that BM is congruent to AM. So if you look at that, you want to ask yourself, well, is that one of our four congruency shortcuts? Okay, and the answer is yes. We have an angle, we have two angles, and we have an included side. So we have two angles and an included side. So what we can say is by angle side angle triangle AMD is congruent to triangle BMC. And again, you want to make sure that your corresponding letters are in the correct order. So since triangle AMD is congruent to triangle BMC, that means that we can assume that corresponding parts of those congruent triangles are congruent. So that means that you first ask yourself, does AD correspond with BC? The answer is yes. So what we can say is by angle side angle, triangle AMD is congruent to triangle BMC. So by CP CTC, we can say AD is congruent to BC, which is what we wanted to prove at the beginning of the question. So that's the first example of how to use our shortcuts in order to prove that corresponding parts of those congruent triangles are congruent. So if we look at this, it says if you use a congruent shortcut to show that two triangles are congruent, then you can use CP, CTC to show that any of their corresponding parts are congruent. So the first question is, are the triangles congruent? If they are, then you can go about figuring out which parts of the triangles are actually corresponding, which means which parts of the triangles are congruent. So let's take a look at a few more examples. It says, in the examples below, state why the two triangles are congruent. What sides and or angles are congruent? Write the congruence statement. Then list all the corresponding parts of the triangles that are congruent. So let's take a look at this. If we have these two triangles, CBA and EDC, we want to figure out what, first of all, we need to figure out, are these two triangles congruent? So let's take a look at what we know. We know that AC is congruent to AE. We also know that AB is congruent to AD. And we know that because you have your little congruency markings on each of those sides. Now, again, you need to be able to analyze these two triangles and figure out, are there any other things that we know are congruent? And the answer is yes. We know that angle A is congruent. We know these two angles right here are congruent. Okay, so we'll call those both angle A. Angle A is congruent to angle A. Now, how do we know they're congruent? Because vertical angles. Okay, those two angles are vertical angles. Now, think about what we know. We have a side, an angle, and a side. Side, angle, and a side. Ask yourself, is side, angle, side one of our congruency shortcuts? And the answer is yes. We said that yesterday that is one of our congruency shortcuts. So what we can say is, by side, angle, side, triangle, we'll go triangle ABC is congruent to triangle ADE. Again, remember, your corresponding angles and your corresponding letters need to be in the right order. So since those two triangles are congruent, we can say that all the corresponding parts of the triangles are also congruent. So it wants us to write down list all the other corresponding parts of the triangles that are congruent. So what we can say then is, if we're going to list all that, so we can say, so by CP, CTC, we now know that BC is congruent to ED, or my fault, DE. Let's see, we know that angle D is congruent to angle B, and we know that angle C is congruent to angle E. Okay, so again, we're able to, because of CP/CTC, we're able to say that all these different parts of that triangle are congruent. Okay, so take a look at this next two triangles. So if we're looking at these next two triangles, again, the question is, are these two triangles congruent? So is QRS congruent to TWX? And if you look at this, if we write down what we know that, so QR is congruent to TW, and angle R is congruent to angle W, and angle S is congruent to angle X. So if you look at that, you have a side, an angle, and another angle. Side, angle, and another angle. So we have side, angle, angle. So the question is, was that one of our 4 shortcuts? And the answer is, it is. So by side, angle, angle, triangle QRS is congruent to triangle TWX. And if we wanted to list out the rest of the the rest of the congruent pieces of this triangle, we could say angle Q is congruent to angle T. We could say TX is congruent to QS, and we could also say RS is congruent to WX. All right. So let's take a look at this next problem. So it says TV bisects angle STU. So angle STU is right here. It's bisected by TV. So what we know about that is that since angle STV is 33 degrees, we also know that this is 33 degrees. So let's take a look at what we know. We want to know, is angle S congruent to angle U? So the first question is we need to prove is, are these two triangles that are created congruent? So if we look at this, we know that angle STV is congruent to angle UTV. And so since those two angles are congruent, let's take a look at what else we know. We know TV. So we know TV is congruent to TV because these two triangles share the side TV. And finally, we know the angle SVT is congruent to UVT. It's angle UVT. So if you think about what we know angle, side, angle. Is that one of our four shortcuts? It is. So we can say by angle side angle, triangle STV is congruent to triangle UTV. Again, you want to have your corresponding letters in the correct order. So since those two triangles are congruent, we can then say, so by CPCTC, angle S is congruent to angle U. All right. Now, when we're trying to prove that triangles are congruent, it can be hard to keep track of what you know. So what that means is, first of all, whenever you have any of these problems, you need to mark all the information on the figure. So anything you know, mark it on the figure. I would also recommend writing it down kind of like we are here. And then second, sometimes these triangles are going to be hard to see. You can use, so if they're hard to, and what I mean by that is you're going to see in these next few problems that we're going to have some triangles where they overlap. And so if the triangles are hard to see, I recommend that you use different colors or redraw these triangles separately. So let's take a look at some more of the, I guess you could call them challenging problems where you have triangles that are overlapping. All right. So what do I mean by that? So what I want to look at is we want to try to prove, okay, we want to prove that triangle or side AE is congruent to BD in triangle ABC. All right. So we want to prove that using this triangle right here, we want to prove this. We want to prove that, I'm going to make this orange, or make it a little bit less thick. We want to prove that AE is congruent to DB, okay, or BD. Now, in this picture over here on the left, all right, over here, this picture is kind of confusing. It's kind of hard to see what's congruent to what letters go where and stuff. So what you'll see is, and here they use different colors. They use what, like a reddish and pink for one triangle and blue for another triangle. But again, even that is still hard to see. So what you can do in order to make your life a little easier, make yourself able to see things more clear, is you can separate or color them to see them more clearly. And what I mean by separate is I can take two triangles I want to work with. I want to work with triangle ADB and I want to work with triangle AEB, and I can redraw them over here like so on the left. Okay, so I redraw them, and now it's more clear to see what pieces are labeled already for me to understand what's congruent. Now, again, what you need to do is you need to mark all the information on the figure so that you know exactly what information you know is true. So if you look at this, we know angle D is congruent to angle E. Why do we know that? Because in the original picture, it tells us that based on the congruency markings. We also know that angle A is congruent to angle B when we know that because of, again, the original congruency markings. So at this point, we were wondering, what other information do we know? Like, do we know that any other pieces are congruent? Because this information alone is not enough to prove that it is congruent. Because remember, we have side, 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 angle, side, angle, and we also have angle, angle, side. All right, or side, angle, angle, however you want to write that one. Okay, so if we look at this, we know we need some more information to be able to use one of our shortcuts. So we need to take a look at this picture, and we need to figure out what else might be congruent in order for us to use one of these 4 shortcuts. So if you ask yourself this, what about EB and AD? Do we know anything about that would help us figure out that that's congruent? The answer is no. Okay, but if you take a look at this, this triangle has side AB, and this triangle has side AB. And if you look at that in our original picture, okay, let me zoom in so you can see what I'm highlighting right here. You can see that the red and blue triangles both share that side. If they share that side, that means, remember we did that up here where the 2 triangles share this side, so we're able to say that it's congruent. So if 2 triangles share a side, we can say that that side is congruent. So triangle AB, or side AB, is congruent to side AB. Now take a look at what we have. So we see that we have angle E is congruent to angle D. We know that angle A is congruent to angle B. And we know that side AB is congruent to side AB. Now think about what we have here. We have angle, angle, side. Angle, angle, side. All right. So angle, angle, side is one of our 4 congruence shortcuts. So what we can say is by angle, angle, side, triangle ADB is congruent to triangle AB, or my fault. Let's use the same thing that they used up here. So we can say that triangle ABD is congruent to triangle BAE. All right. So now, since we've proved that these 2 triangles are congruent, we can go back and talk about what we wanted to show. We wanted to show that AE is congruent to BD. Well, AE corresponds with BD. So by CP, CTC, AB, or my fault, AE is congruent to BD, which is what we wanted to show in the first place. Okay, so again, when you have triangles that are, overlapping like this, I would highly recommend that you take the 2 triangles and just pull them out and draw them separately so that you can clearly label what you know. So let's take a look at a few more examples. We're going to do one more where they don't overlap, and then we're going to do 2 problems where the triangles overlap to see a few more examples of those. So let's take a look at this first problem. It says in the following diagram, AB is congruent to ED, CB is congruent to CE, and angle B is congruent to angle E. Is triangle ABC congruent to DCE? How do you know? Okay, so first off, remember, to make these problems easier, what you want to do is you want to label, you want to mark everything that you know. So AB is congruent to ED, CB is congruent to CE, and angle B is congruent to angle E. All right, so our question is triangle ABC congruent to triangle DCE? So is ABC congruent to DCE? And so initial thought, you might say, hey, I have a side, angle, and a side. Side, angle, and a side. And you're like, yeah, they're congruent. But you want to pay attention to what this says. Okay? Remember, when you write congruency statements, the corresponding pieces must be in the right order, in the same order. So So what we know is these two triangles, they have enough information to say that they are congruent. But look at this. A. Does A correspond with D? Check. B. Does B correspond with C? Angle B does not correspond with C. This would mean that angle B is congruent to angle C. Angle B is not congruent to angle C. Angle B is congruent to angle E. Okay, so this statement right here is not true. Okay, not true. If you wanted to make this statement true, all right, you would have to say triangle ABC is congruent to triangle DEC. Okay, you have to have, remember, corresponding parts have to match up in your congruency statements. So this is true. The original statement that they had is not true. All right. So make sure, again, the reason I want to look at that is because you need to make sure that your corresponding parts are in the correct order when you're writing your congruency statements. Otherwise, it would be incorrect. All right. So here we go. We have two overlapping pieces here, so it can be kind of hard to see. So if you look at this, you have triangle ABY. I'm going to draw that over here. So triangle ABY. Again, you want to make sure you label everything the way it should be labeled. So AY has a congruency marking on it. Angle Y has a right angle on it. Okay, there we go. And then we have angle, we have triangle AXC. Okay, so we have AXC. AX is congruent there, and then we have a right angle there. Now, we want to, in order to prove XC is congruent to YB, so in order to prove that XC is congruent to YB, we would need to show that these two triangles are congruent. So again, look, I took the two triangles that were overlapping, I redrew them over here so that they're easier to work with. Now, we have two pieces that we know are congruent. We need to figure out we need to figure out at least one more piece that's congruent in order to figure out whether or not these two triangles are congruent. So if you look carefully at these triangles, let me erase these colors over here, you'll notice they both share angle A. So we know that angle A is congruent to angle A because, again, remember, if two triangles share a same side, that side is congruent to itself. If two triangles share a same angle, then that angle is congruent to itself. So angle A is congruent to angle A because they are the same angles. Now, if you look at this, angle, side, angle, angle, side, angle. So you have a corresponding angle that's congruent to corresponding angle. You have a corresponding side congruent to a corresponding side, and a corresponding angle that's congruent to a corresponding angle. So what does that mean? Is that one of our four shortcuts? It is angle, side, angle. So by angle, side, angle, we know that triangle ABY is congruent to triangle ACX. Again, remember, A corresponds with A, B corresponds with C, Y corresponds with X. You got to make sure that's in the right order. So by CP/CTC, we know that BY is congruent to CX, which is what we wanted to show. I wrote it the other way around, same thing. You could write it that way, and it's the same thing. All right. So again, when you have overlapping triangles, highly recommend that you redraw them. So let's take a look at this next problem. All right. You have okay. So you have, if EF is congruent to HG, EG is congruent to HF, then prove that these two angles are congruent. So let's take a look at this. I'm going to redraw these triangles. I have triangle 1 right here, so I'm going to redraw that triangle. We'll draw it in green since I highlighted it in green. So we have here, 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 and that is FGE. And then we also have the second triangle over here. Yeah, I'll highlight that in blue, so I'll draw it in blue. So that is in this orientation. So we have F, we have G, and we have H. And so let's mark what we know. So we know that EF is congruent to HG. We know EG is congruent to HF. So EG is congruent to HF. And then we want to prove that these two angles are equal. All right, so your first thought might be to look at, well, they both have F, but in this triangle, F is a right angle, and in this triangle, F is not. It's an acute angle. So they don't share, that angle is not the same for both of them. It's not the same type of angle. So then you want to take a look. They both have G, but again, in this case, G is a right angle, or it looks to be a right angle, and over here, G is not a right angle. So again, we cannot use either of those angles, and E and H are angles that are, we don't know anything about them. So let's take a look at this. If you look at this carefully, you see that these two triangles actually share FG. So if the two triangles share FG, that means we know FG and FG is congruent to FG. So now, if you look at this, we have three sides that are congruent. So we can say by side, 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 triangle EFG is congruent to triangle HGF. And so because that is true, then by CPCTC, angle EGF is congruent to angle HFG. Okay, so that is the final example. And when you're doing these, okay, remember, you want to use 4 shortcuts, label everything you know. You want to redraw overlapping triangles, and then the other thing, pay attention to corresponding parts in congruency statements. Okay, so go ahead, start working on your homework. This is the only lesson we're doing for this homework assignment. So again, this is the important stuff right here. If you have any questions, message me on Remind or email me, and make sure you ask questions about the homework in class.